Okay, so welcome back. This is third lecture for the week 3, and as we were looking at the concept of population towards the end of the last lecture, so we'll start from there. So you will start from the same same slide that we left in the previous video, which was trying to look at the population. So there are different ways you can forecast the population. Why first of all, why it is important to forecast population? So whenever we design any infrastructure, say it doesn't matter whether you are trying to do transportation, you are trying to do cell phone usage, you are trying to do electrical like energy usage or energy projection, how much energy will be required in future. We need to know the population of that particular area where we are concentrating our projects on. So irrespective of your discipline, as I keep on telling in this course again and again, this the whole concept of this environmental science and engineering course, we are calling it engineering, but it's essentially an environmental science course as per the Honorable Supreme Court judgment. That's the kind of the motivation for offering this particular course. We are trying to highlight how the different concepts are important, irrespective of the discipline that you are going to work or you might be already working on. So we need population means demand on resources, isn't it? So depends on more the population, more the demand on resources. So there are so many times what we need to do is we need to project the population. We need to look at the population for next 25 years, next 50 years, or next 20 years, depending on your project. So when you are looking at this projection, there are different ways you can project it. So there are different methods out there. So we'll try to talk about those different methods and then have some conceptual discussion around the population, and then look at the historical trends in population as well. So in terms of the population forecasting method, there are standard methods by which these are the you can look at any classical textbook where this topic is discussed. You will find this method: arithmetical increase, geometrical increase, incremental increase method, simple graph method, decrease rate of growth method, comparative graph method, and the master plan method. So there are different methods out there. So we'll discuss some of these methods as well. So some of those are obvious, like when we say arithmetical increase or geometrical increase. Geometrical usually means that it's a more on an exponential curve, and it also depends on the area, like where with which region. Some region at this particular time we are seeing a huge growth in population. In some areas the population is more or less the constant. For example, I was visiting Chicago a few weeks back, and there one thing was that the main metropolitan city of Chicago is not seeing any much increase in population. Population is more or less constant. When you go outside, when you look at the suburbs, population is increasing. If probably, I don't know, we have to look at the data, but if you think about in big cities in India, again it's the suburbs where the newer and newer population is coming up. The construction within the main core city, like when we talk about NCR for example, outside Delhi lot of development. Within Delhi, newer and newer construction is lesser and lesser as we make as we go ahead in time, because it's already saturated. We don't have a space to make new flats, new apartments, new bungalows within the Delhi, like the core area. But yes, when we go beyond the core area, still a lot of development is happening. So let's start with one example here. Say if you have some data which is from the census department for a city A, just I'm not giving a name, just any city, or if you look at the population data, in fact we should not call it a city, we should call it a town, or it's a very, very small city. So now it says find the probable population in the year 80s, 90s and 2000. So we have given us some data, and as you know, in India we have census every 10 years. The last census was 2011. The next will be 2021. So if you look at for any particular city, even you go to that city website, you can find the historical population data as in an increment of 10 years. So you will find 2011 data, 2001, 1991, 1981, 1971 and so on and so forth. So we have some data already. So we can take that data and try to see what was the trend, and based on the trend that you see with those data, you can project what will be the data, what will be the population in future. So that projection can be done assuming that the growth was kind of similar over decade after decade after decade. But say for example, if you had a huge industry coming by, if say there was a big university got built up, or anything like something happened in one particular decade, and then for the next decade you will see the data will not follow the same trend which it was following earlier, because there was certain the growth was not similar to what was happening in the earlier decades, because something new has happened. So and then you may not the method that you use for projecting may be different. So let's look at this example. So we have been given data of 1940, 1950, 60 and 70. So 4 decades of data is provided to us. So this is the data right there, and the population is provided to us in terms of 8,000, 12,000, 17,000 and 22,500. So this is the population data for those 4 decades. That means that in 1980 the population was 8,000, which increased to 12,050, increased further to 17,060 and increased further to 22,500 in 1970. So taking this data into consideration, the problem is asking us, the question is asking us to project what will be the population. It says find out the probable population in the year 1980, 1990 and 2000. So we have been given data for 4 data points are there. Using that 4 data points, we will try to project what will be the population of the future. So let's see how we can go about doing that. Okay, so what are the different methods? Let's start with the arithmetical increase method. So we have been, this method is, what is the concept of this method? It assumes that population is increasing at a constant rate. So there is an arithmetic increase. So there is a constant rate of increase in population. So since we have data for certain decades, we can find out the rate. Using that rate, we can project what could be the population in the subsequent decades. So simple equation is used for that, which is provided over here, which you see Pn is equal to P plus n times C, where P is your population at present n, which is and then n is the number of decade, C is the constant determined by the average of increase in n decade. So now if you look at in terms of the population here, so we had 1980, 1950, 1960 and 1970. So these are the, so from 8,000 to 12,000, so increase is 4,000. From 12,000 to 17,000, so we have increase of 5,000. From 17,000 to 12,000 to this, so increases 5,500. So if we take average of these three, average increase is 4,833. So that's the average increase per decade. So that's the average increase in population per decade. Now taking that number into consideration, we'll go to the next step, and okay, so we'll try to project now how will, so average is for 4,833 per decade. Now for 1970 population was 22,500. If you remember from the previous slide, this was the 1970 population. This was the population of 1970. So 1970 we had 22,500. Now 1980, since average increase is 4,833, so you and we are talking about 1 decade from 70. So that's why we have 1. This is the average increase. So that's your P plus that N times C. So 1 decade and C is the rate of growth, and you got 27,333. Now when you go to 1990, you have 2, because we are talking about 2 decades from 1970. The baseline that we have, because this is the actual value, so that's where we start from. So 22,500 plus 2 times the increase, so we got 32,166. Now if for 2000 we have 3 decades, average rate of growth, and we get 36,999. So, this is how we calculate using the arithmetic increase method. Similarly, similar formulas and the things are there for the geometric increase method. Again, these concepts are very, very important when we will look at water class, water during the week when we cover the water. During the week when we talk about wastewater, during the week when we talk about solid waste, everywhere this concept is used, because any infrastructure, and this is, since we are talking about environmental field, we are talking about these like water, wastewater, solid waste, but if even for energy projection, transportation usage, buildings, how much you will use, the kind of infrastructure that you need to develop, everywhere the population data is important for anything that you will do for the city. Any infrastructure that you will create, any services that you will provide, whether it's a hardware services, software services, everywhere having, because what population is the market, isn't it? More the population, more consumers, more demand. So that's why the population data is very, very important. The population forecasting methods are a very basic concept that is used throughout different disciplines, and this is how it is done. So it will be useful for, in fact, any professional that will be doing any sorts of work related to where you need to provide services, you need to provide even if you're trying to come up with a newer product, you need to look at what will be the market for the products in future. So all these things will be useful for you in terms of this basic, and I don't think this gets covered in any other course unless you are designing some stuff. Maybe it does get covered in some course. So there is how, as I said, we'll try to have some basic concept associated with population as well. So when we say the growth in population, the previous example we use this arithmetic increase method, but that again is one way of doing it, but there are a lot of other ways. So when we talk about population growth, it's just like making beer. Like when we make beer, I don't advocate that you consume liquor, but it's when we talk about beer formation or in terms of any fermentation process, population growth modeling follows the same exponential trend as yeast, which is growth during fermentation. So when we are talking about fermentation process, it's the population is increasing at the same. So beer is what? Yeast plus malt, which is and sugar and some hops. Sugar acts as a food for the yeast. Yeast consumes the sugar, multiply, produces alcohol and flavors as a waste product. So population is kind of a function of environment. It's the people and the resources. So the people which is there, they reproduce, more and more babies are produced, and also environment plays a very important factor. Say many places because of say if you're in the war zone area, if you are in certain how your surrounding is set up, you will see impact on population growth rate. Like population growth rate depends on how the impact will come. So it's again here. It's just as the population of this bugs increases, the yeast increases inside the favorable environment with the resources available. That's how the human population also keeps on increasing. If we have, say, if you are in an area where there is no resources, and then you will not have much population increase in those areas. With the places where you have high resources available, your population will be higher in those areas. So taking that example of that of beer or fermentation, if you look at the bulk cell number initially as a function of time, so there is an increase. As you can see, as there are two lines here. This red line is showing you the bug food, the food which is available for the bugs, and the black line is showing you the bugs population. So this is the bugs population line. So in that population line, as you can see, initially food is available. Food is available, it is being consumed. Increase in population. No more food available, you see starvation, and finally some death. So the growth is exponential when the food is available. And how the food goes down? Initially a lot of food, then it's getting consumed, and then it is coming down zero. And once the food is coming down to zero, at the same time you start seeing like a stagnation in population and even decrease in population with death and all that. So that's how population is a function of resources. As a more resources are important for population to increase. So animals and human population, when we talk about growth, is also exponential. Sometimes its growth is quite exponential. The picture that you see on my on the screen on there is actually lots and lots of people. Although from a distance it may you may feel like it's something else, but actually what the picture that you are seeing here is essentially a huge number of people there. So, and that's we do see this kind of stuff in some sort of festivals, some big programs or other stuff. Like we recently we had this Rath Yatra in which is celebrated in a big much fanfare in the eastern part of India. So you will see these kind of crowd in Jagannath Puri during this Rath festival. So similar things you will see at some other, even Kumbh Mela and all that, you may see these kind of crowd over there. So, and Durga Puja in Kolkata brings crowd, but not as compact as you see over there, because it's it is crowded, but it's not as crowded as being seen in this picture. So many times the human growth or the animal growth is also exponential. Where exponential, as you know, it's p is equal to p0 e to the power of rt, which is the very basic exponential equation. You can use this equation like p is equal to p0 e to the power of rt, where p is the future size of population, p0 is the current, t is the number of years, and r is the assumed constant growth rate. Now rate is often expressed as a percent. So for example, New Zealand's current population growth rate is 1.4%. If you look at the India number, we'll use that in one of the problem. So the different countries have different numbers. Population growth rate in European countries are actually much less, and that's why many of these European countries, we say that they're aging, and Japan as well. Asia, India, China, still the population growth rate is pretty high. China is slightly lower than India. That's why we will overtake China, although we don't want to overtake China in terms of number of people, but based on the growth rate, we will be overtaking China in terms of in terms of the population, total people in the country. So that's so you can that's your exponential growth. We can use that. So growth rate, that R, is defined by 4 factors. So there are 4 principal components. Now what are those 4 components? Birth rate, death rate, immigration rate, and immigration rate. So there are I and E. I is the immigration with the people coming into the country. E is the immigration for people going out of the country. So these numbers are important. Like for a country like India, we have actually more people going out of country than people coming into the country. So that's our E will be higher, I will be lower. Birth rate is there, like how much babies are produced and how much babies are born, and then we have death rate, where death rate is going down over the years. In some countries, it's because of a lot of medicines are available, medical services are available. So especially in the developed countries, so developing countries are also doing better. That overall life expectancy is increasing throughout the globe, but developed countries are doing much better than developing countries on that matter. So with the medical facilities, with the medicines and all that, people are living longer. You can always debate that is it really worth living on all those medicines and other stuff for a long time. That's a philosophical discussion. When we meet in person, we will do that. But right now, because that's a whole, probably we can discuss that for hours and hours. But coming back to that, the fact is, birth rate is still decently high, death rate is going down, immigration rate in country like India is not that high. We are not getting many people coming into the country. immigration, the I part is not that high. The E part is still decent. We saw a lot of people going out of country. No, I'm not talking about those famous people who went out of country because of some quote unquote other reason. I think you got it. So we are not talking about that in general, like people, professionals and other stuff going to say US, Canada, Australia and Europe and other places for jobs, for better life and whatever. So that's the immigration, E with the E, not the I. I is it will be I for those country. Say if you are sitting in Canada, the people coming in is more, people leaving Canada is less. Same thing in US, people coming into US is more, people going out of US is less. In India it's the opposite. In people living India is more, people coming into India is less. So that's how these are the four factors. So R is defined as, so when we talk about R, it is defined as B minus D plus I minus E, which is pretty obvious if you just think about from a common sense. B is the birth rate, D is the death rate. So B minus D, mass balance actually. B minus D. So you have birth rate minus death rate. More and more people coming into this, like being born, but if whatever people is dying, so whatever is the if you say if we had B is equal to D, say on a particular day, if 100 babies are born and 100 of us pass away and then go like we die, so B minus D will be 0. But usually B is higher, D is less, because and as we make more and more progress in terms of our medical stuff, D is lower and lower, B is getting lower too, but B still is pretty high. So B minus D is a positive number. Similarly, I minus E, I is the immigration, E is the immigration, people going out. So in a country, for a country like India, I minus E will be it will be in a negative. So, but if you are in other countries like developed countries, this will be in a positive way. So so you calculate this based on these four factors. So birth rate, death rate, moves in and out of country. That's kind of gives you estimation, different rates to come up with population of a particular country. Now, factors affecting birth rate, number of children, age of bearing children, infant mortality, health of population. We'll talk about, we'll discuss it later. General age of population, age of death versus period of fertility, education level of population. So those are different factors there as well. People are these days, even in India, many young couples, they are sticking with one children, maximum two. You don't see more than two children. And if you think about my father was there, including my dad, is 4 brothers and 4 sisters. So there were 8. And on my mother's side is also like that. So they were, and in our case, we are lower than that. Like I have a bigger family, but more of them has 3 or 4 maybe. Mine was, I have 4 siblings. So so from our generation it has gone down. For people like us, we are having 1 or 2 child, like couples like us are having 1 or maximum 2 child, and many couples these days don't want to have child as well. I'm talking about in Indian context only. They don't want to have kids. They just for whatever reason, it's a personal choice. We don't want to I don't want to comment on that. It's a personal choice, but there are a good number of couples out there who they don't want to have any kids. So they are just that's okay for like whatever they decide. But so these are all different effects that how the society behaves, how the society does. It has an effect. So number of children that per family, it's kind of going down over the years. Age of bearing children. So now earlier people used to marry relatively younger. Now as the couples are marrying little bit later in the age, so the age of the bearing children is also there. Typically it says that you should have I'm not a medical professional, but people like around 30 is a good time to have your kids, because by the time you retire, the kids are well settled. But that's again different discussion. So, age of bearing children, the people are getting married late. So, that is also affecting. Infant mortality has gone down comparative to earlier. Earlier, more and more people more and more children used to die at the age of 5. That has gone down. So, that is having a positive effect on increase in population. Health, if overall health is good for the population, the chances of having more kids. General age, again, age of population is also important, like if it's more older, like right now India is a younger country, Japan is a more on an older side, many of the European countries are on the older side. So that also has an effect. Then age of death versus period of fertility, like how long you can have fertile age so that you can have more babies are born. So, and then education level of population. So, if you are more educated, more usually they tend to have less children, but there is no really correlation on that. Poorer people earlier, especially when there were a lot of farming activities, still today when the farming is a lot of human labor based farm agricultural activities, more the hands, more people can go out and work in the farm. So, that was a kind of motivation behind having more children, so that people will the kids will go out, when they grow up they will go out and help in the agricultural activity, but those things are changing now. So, but these are the ones which affects the birth rate. Similarly, for the death rate is the natural lifespan which is increasing. Availability of health care, which we talked about, again getting better. Care provided to elderly, which is again we would like to have in a much nicer than what it is today, but it's again they are all making positive progress. Occupational risk, that is also coming down, like risk in terms of working in the factories and all that, although time to time we do see accidents happening, like recently we saw one accident happened in Kolkata metro, or that was while traveling, which is really unfortunate. And even in the factory settings, time to time we do see some, but the frequency of those kind of occupational hazard risk is actually going down. Social stability also, like how stable is the society, that also affects in terms of death rate. Dietary factors, eating habits, lifestyle, smoking, drinking and all those, so those things are also part of how it affects the death rate. So, if you look at the population over several, like since maybe humans existed, from almost minus 5000 BC to as of today, if you look at the global population in this particular map, which is the y-axis is global population presented in millions, like million people. And earlier from the Stone Age, Bronze Age, Iron Age and Middle Age, and then the newer like a present age, as you can see over here. Initially the population was very like a low. Remember, this is in million years scale, so that's why you don't see much increase. There was some population, this is not actually zero, but there was some population, but since the scale is in millions, we don't see much effect here. But after as we move into AD, right before that, we see we saw some increase in population, but in between the Black Plague happened, and then that reduced a considerable population. Then there was some other events as well, which we'll talk about in next few slides, maybe in the next video, where how several natural events have impacted the population growth. But as you can see, for the last 200-300 years, there is a sharp increase. So, as there is a sharp increase in the population has like a shoot up, and that's really has lots and lots of impacts on resources from Mother Earth, because so many people. So that means we need to have housing for these people, we need to have food, we need to provide all the different tools and gadgets and other stuff that people use today, and all of them requires resources. And that resource management has become very, very critical. And without resources, you cannot really run any profession for that matter. So this resource management has become very, very important, because there is a lot of demand on resources, and that how the concept of sustainability and all those things also came into existence. So as you can see, that population historical trend in population. So, if you look at population from earlier, world population AD 1 point equals to 1 million people. Initially, like we have 170 million, then we have 1 billion people 1800 AD with the industrial age. You see you start, if you look at the map, India and China in North America, in the Western Europe, the European countries, you start seeing more and more dots. One dot means 1 million people. It's still like 2 billion. So, and then in 1930, 60 we hit 3 billion. In 75 we hit 4 billion, and you see the India, China and other places are totally getting lots and lots of white dots. 5 billion in 1987. So, we hit 1987 5 billion, 1999 we hit the 6 billion. So, you look at the number of years we are taking to go for 1 billion to like an increase of a billion is much faster. Then 2030 we are projected to hit 8 billion, and as you can see, huge population, mostly like a lot of population in Africa, Europe, Asia, and in South America along the coast. Same thing with North America, not that much in Canada side, more on the US side because Canada is too cold. Australia, New Zealand also, the population is increasing, it's the information age. So, and as I was telling, that time it took to population to double is, as you can see, from increase by 1 million. Initially it took like 1 millennia, then 124 years, then 33 years, then 15 years, then 12 years. For last 5, 6 and 7 billions we had just an increase of 12 years. Then it's projected that it will be 13 years, then 14 years, 18 years, and then again it's kind of going back up because in rate of growth in population is actually going down. So, that is why you see this data. So, just let us look at this slide and then we'll stop. So, global growth rate for like 2005 to 2010 was around 1.2%. If we don't reverse that growth rate, if we just keep at 1.2%, population will be 11.1 billion by 2050 and 15 billion by 2070. That's a lot of people. So, by 2070 we will be almost double of the people that we are today. Still today we feel that many places are too crowded. So, but see, Mother Nature has own way of correction. So, we will probably see some corrections happening. So, overall growth rate is slowing due to change in population. More and more people are older. Social dynamics, sustainable living, people are realizing that impact on resource, affluence, education. So, as you can see, by 2010 it is 1.2, but by 2050 we assume that we project that population growth rate will actually go down to 0.5%, and then by 2095 it will be to 0.1%. So, it kind of will be stable around at the end of this century. So, let us stop here, and we will continue this discussion on population in the next video as well. So, let us take a stop. Again, this was the third lecture for the week 3, and I encourage you to use the discussion forum for all sorts of questions that you may have, and we'll be happy to discuss that. So again, thank you, and look forward to seeing you in the next video.